but that's really not necessary for operation. When this physically vibrates, you can actually feel sometimes a cool wind blowing off, like an ion wind. And that's what's really amazed me about this unit, that with no power you actually get the strongest effect I've ever felt. This diagram shows an oscillator using a half-wave coil connected to two solid metal plates. Nikola Tesla gave a paper on the use of this type of oscillator for electrotherapeutic purposes in 1898. He states, "In my first experiments, I used two metal plates as shown, but later I found it preferable to replace them by two large hollow spheres of brass covered with wax of a thickness of about 2 inches. In this manner, the unpleasant shocks to which the experimenter was exposed when using the plates were prevented." In 1963, Borderland Sciences Research Foundation published a schematic from Bob Beck which was claimed as an adaptation of Lakhovsky's first patent. The MWO maintained a constant interest, and this MWO handbook was published a quarter of a century later with the current BSRF research file, including many of the diagrams shown in this video. Beck's basic unit consists of a quarter-wave high-frequency coil. This diagram shows a basic oscillating circuit driving such a coil. Two concentric ring antennae, somewhat at variance from Lakhovsky's, are connected to this unit with a single wire to each, as in Tesla's diagram, one from the high-frequency terminal and the other from ground. This wire is usually connected to the second ring, as in a Yagi TV antenna, but can also be connected to the center. This is a Bob Beck multiple wave oscillator, and what we have here is a basic oscillating circuit comprising of a spark gap capacitors, one small tube, and a Model T coil. And that circuit drives this small quarter wave Tesla coil here, which pushes the high frequency out the end, upon which there is an antenna hookup. Now the antenna we're using in this one was made by Riley Crabb by taking a piece of plexiglass, spraying it with adhesive, and laying a sheet of aluminum foil on it. And then using a special jig he made, he would cut out the rings. And as you can see on here, this ring here is slightly larger than this one. So it's the excited ring. This gives off a pretty good shock. Now the antenna can also be driven from the center. So we'll use a golden ratio antenna, which has been drilled in the center. Here we have an interesting Beck-style multi-wave oscillator. This one has a quarter wave coil in it, which drives the main antenna here. And coming off the ground end of the antenna, we have a resonator antenna. And now the subject would sit in between these two facing each other, and put their feet on the ground plate here. And this also has a well inside the coil on the end, which people would place things like homeopathic medications and vitamins in to try to broadcast them through this unit. I'll turn it on and see how the antennas look. Again, we see the arc between the rings. Mostly off the driven element, but it does come in. And on the resonator antenna, you don't get any arcing, but to touch it, you really get a mild shock. This multiple wave oscillator also has a little argon bulb attachment for application of electricity directly to the body. We'll turn this on. The argon bulb principle was utilized in these units known as violet ray massagers. This one was made by the Renew Life company in 1922, and it has a high frequency coil driving this small bulb here. Many cures were claimed for these units, but would you bet your life on it? This unit is a variation on the gas bulb theme, has a high frequency coil driving these gas tubes, and is alternating argon and neon in them. And this unit is used to stimulate circulation in the feet. Get a mild tingling and smell a lot of ozone. This multi-wave oscillator was built by Mike Brown of Pleasant Hope, Missouri, and it has a quarter wave coil with a single high voltage terminal feeding into the antenna, and it has a fan inside for cooling the circuit. It blows out here. There's no visible arcing on the antenna, so if we bring a screwdriver nearby, we can see that it is still quite energized. This unit also has an argon bulb attachment. We can see that the bulb reacts much more to the coil in this unit than the antenna does. This multi-wave oscillator is made by Clark Kent of Super Science in